Now let's just move on further towards the next theorem, which says that a quadrilateral is a parallelogram if a pair of opposite side is equal and parallel. So let us suppose if I'm just taking a quadrilateral, so we have to prove that this is nothing but a parallelogram. So let us suppose this is my quadrilateral that I'm taking, and I am just taking it as nothing but A, B, C and D. Furthermore, A, B, C and D. Furthermore, it says that given condition is a quadrilateral A, B, C, D, in which a pair of opposite side is equal and parallel, in which AB is nothing but is equal to CD or DC, and AB is parallel to DC is given to us. Let us suppose it is given to us. So let us suppose if I'm just joining this AC diagonal. So what we have to prove over here, we have to prove that ABCD is a ABCD, a quadrilateral is a parallelogram if a pair of opposite side is equal and parallel. Means we have to prove that ABCD is a parallelogram. It is a parallelogram. So let us suppose if I'm just starting the proof of it. So the proof of it, so this is true proof. So the proof of it should be like, let us suppose if I'm starting with the two triangles over here. So we have the two triangles as in triangle ABC and ABC and the triangle ADC. So I'm just taking the two triangles over here. This is my triangle 1, this is my triangle number 2. So first of all, it is given to us that AB is nothing but is equal to DC. It is actually a given condition to us. Furthermore, we know that AC is nothing but is equal to AC. It is nothing but a common arm and furthermore we can say that these sides are actually equal to each other. Furthermore, we can say that since AC is nothing but a transversal, since AB is parallel to DC and AC is a transversal, it implies that the angle DCA is equal to the angle BAC, means this angle is actually nothing but is equal to this angle. So if these angles are actually is equal to each other, so what can we say from these three things? That the triangle ABC is actually congruent to the triangle ADC by SAS congruence criteria. By SAS, we can say that the two triangles are actually congruent to each other. And if the two triangles are congruent to each other, it implies that AD is nothing but is equal to BC by CPCD. So what we are getting over here, we are getting that AD is coming out to be is equal to BC. AD is actually coming out to be is equal to BC. So it means that the both sides of a quadrilateral are equal, and this is nothing but a property of a parallelogram in which we have both the sides are coming equal to each other. It implies that ABCD is nothing but a parallelogram. It is nothing but a parallelogram, and this is exactly what we have to prove over here, that if a pair of a side is equal and parallel, then we have to prove that a quadrilateral is a parallelogram. So this is nothing but the proof of this theorem.